Firstly, let me solve the problem 1. First, we have this equation to find the value of the f of y. And when x is less than 1 or x is bigger than 2, the derivative of gx is equal to 0. So the fy has no definition at this area. And then at other values, firstly, let me look at when the x is bigger or equal than 1 and less or equal than 2. At this time, the y equals to minus s plus 1. And from this equation, we could get the value of little f of y. It is equal to the little f of x of 1 minus 1. And when the x equals to 1 or the x equals to 2, the y equals to 0 or minus 1. And when y equals to the minus 1, there is other value of x is x bigger than 2. And the probability of y equals to minus 1 equals to the probability of x bigger than 2. And we ignore the point of the point at this when y equals to minus 1, because just 1 point at the continuous probability density function, it doesn't matter. So that when the y equals to minus 1, the probability is 1 minus the big f(x) of 2. And then the probability of y equals to 0 equals to the probability of x bigger than 0 and less than 1. And plus just 1 point. This doesn't matter. So that it is equal to the big f(x) of 1 minus big f(x) of 0. And the other point, the last point, is the probability of y equals to 2. It is equal to the probability of x less than 0. And this is equal to the big f(x) of 0. So that from above we could get the value of little f of y. When y equals to 1, this is equal to 1 minus f(x), big f(x) of 2. And at the point y equals to minus 1. And when y bigger than minus 1, less than 0, this is equal to the little f(x) of 1 minus 1. And when y equals to 0, this is equal to the big f(x) of 1 minus big f(x) of 0 at the point y equals to 0. And at the point y equals to 2, this is equal to the big f(x) of 0. And otherwise, the value of little fy of y is 0. And the big fy of y, when y less than minus 1, there is not little fy of y exists, so the value is 0. And at the y bigger or equal to 1 and less than 0, the big f of y equals to the probability of 1 minus s less or equal than 1. And it is equal to the probability of minus s less or equal to y minus 1. It is equal to the probability of x bigger or equal to 1 minus y. It is equal to the probability of y minus the probability of x less or equal to 1 minus y. It is equals to the probability equal to 1 minus the big f(x) of 1 minus 1. So that this is 1 minus the big f(x) of 1 minus 1. And at the y bigger or equal to 0 and less than 2, we all know the little fy of y only has one value at the point y equals to 2. So when y less than 2, this is 1 minus big fx of 0, and after y bigger than 2, the big fy is equal to 1. And then we draw the graph of little fy of y and big fy of y. Firstly, this is at minus 1, this is equal to the 1 minus big fx of 2, and then this part is equal to little fx of 1 minus y. And then when y equals to 0, the probability is big fx of 1 minus big fx of 0. It is this point. And then at the point y equals to 2, it is equal to the big fx of 0. And then the big fy of y from minus 1 it is started, and then it is equal to the 1 minus big fx of 1 minus y at this point. And then when it is between the 0 and 2, it is equal to 1 minus big fx of 0. And then after y equals to 2, it equals to 1. That's all the solution of the question 1.